Alright, this is part 2. I was having a hard time at the end of that part 1. Sorry. I had to find some equations in order to find the axis of the symmetry. So basically this is our equation, which we should know. X equals negative b over 2a. And so depending on the equation, we just plug in the b value and the a value and we can solve for the axis of symmetry, which is also going to be our x value for the vertex. So that will be how we find that. So let's see. If we have our standard form is ax squared plus bx plus c. We're looking for the a value, we're looking for the b value for our equation. The b value here, do you agree? There is no x value, so we're going to have 0. Negative 0 over 2 times 2 is 0 over 4, which is 0. This will get us x equals 0, which is a lot of them are going to be, the axis of symmetry will be right on x equals 0. When x equals 0, that is this line. So that's the axis of symmetry for this equation. Now, there's a little mistake here. This is supposed to be an x. Whoopsies. So if this is the equation, whenever we have a b value, that's when it moves it left or right. Okay, so that's going to be, this is another equation. I just wanted to try the axis of symmetry twice with 2 different situations. So we're going to try this one now. I'm going to put that x in there. Problem. Okay, so then we take our equation for some axis of symmetry when we say x equals negative b over 2a. b is negative 2, so the opposite of b will be 2. X equals 2 over 2 times a, which is 3. So it's going to be x equals 2/6, which is 1/3. Okay? So that is our axis of symmetry, x equals 1/3. So then when we're doing our, it's kind of a weird axis of symmetry, but that's alright. We have, it's not right here, it's actually, here's, let's say this is 1, this is 2, this is negative 1, this is negative 2. X equals 1/3 is going to be right about here, so it just scoots it over just a little bit. Should be vertical. Alright, so that is a key part of our parabolas, so in our graphs of our quadratics. Now that value we use, so it's kind of got a couple things that it's helpful for. Once we find that, we're like, oh sweet, now we can find the vertex. So if we take this first one, I'm like, okay, x equals 0, so the vertex is going to be 0 something, and I need to find out what that y value is. All you need to do is take this equation, plug in 0, the equation I got from right here, and I'm plugging in the x value to find the y value. So I have 2 minus 9 equals y. When x is 0, y is going to be negative 7. So the vertex is either our minimum or our maximum point. If we know x is 0, is our axis of symmetry, the x value is 0, we plug that in to our equation and we get negative 7. That is a huge, huge important point on our graph. We go over 0, down 7. 5, 6, 7, and bingo bango. That is either going to be a minimum or a maximum. Now, do we know if this graph opens up or down? Is it happy? Is it positive? Or is it negative? It's going to open upward. So it's actually going to open upward like this. Okay, so the axis of symmetry is right here on the y-axis, where x equals 0 is the equation of that line. Our vertex is our minimum point. This is our vertex, and it's a minimum. Okay, so we're going to talk about those 2 topics today big time. Axis of symmetry, remember, is going to be a vertical line. That is the equation of it. The vertex you use that same equation to find the x value, then you plug that x value into the equation to find the y value. So we're going to do this. All right, here's our first equation. Find the axis of symmetry. We are going to use our handy dandy memorized formula, negative b over 2a. We look up here and we're like, b is 12. I'm going to get negative 12 over 2 times negative 2, because a is negative 2. You could even write that down if you want. A is negative 2, b is 12, and c is negative 7. Those are our a, b, and c values. So we solve this and we get negative 12 over negative 4, which is 3. X equals 3. That is our axis of symmetry. We plot that on our graph, which is going to be a vertical. Oh boy. Vertical line. That probably would have been drawn better if I would have just done this. Yep. So that is important. Then the next step is to find the vertex. Well, we already have part of it, so don't make any more work for yourself. We know the x value is 3. Bingo bango, we already found that out up here. So then we plug that into our equation, which we plug in 3 for x into the original equation, and we solve it using order of operations. Hopefully I didn't make a mistake. I'm going to add my negatives and get negative 25 plus 36, which is a positive 11. So my vertex is over 3, up 11. 1, 2, 3, 4, 5, 6, oh that's 10, and then 11 right here. So far I have it kind of centered where it needs to be. This is my center line. This is my vertex, so I know how high it is. Now I need to look at some of the things that we learned yesterday. This negative sign is going to mean that it's flipped upside down. So I know it's coming down this way, but I don't know how fat or how skinny it is. So that's where we have to check another point. But we know that it's coming downward because of that negative. So let's check. What's an easy one to check? Oopsies. I erased that special point. What if we put x as 0? Pretty easy to check, right? If x is 0, then y is negative 7. Okay. 1, 2, 3, 4, 5, 6, 7. And what do we know? It's symmetrical, so that far down here, we're going to be that far over here. I have enough points to graph my parabola now. Whoa. Do a little bit better job than that, sorry. Okay, so that is using the axis of symmetry, finding the vertex, and then just plotting an easy point on one side can find you that other one. So when we have, this would be 6, negative 7. And we don't even really need to find any others. Okay? Let's go ahead and try another one. Find the axis of symmetry. Our formula is x equals negative b over 2a. A value is 3, b value is negative 6, and c value is 2. If I do negative b, I'm going to get 6 over 2 times 3, which is 6 over 6, which is 1. My axis of symmetry formula is x equals 1, which means I have a line right here at x equals 1. That's my line of symmetry. My vertex is going to be either my minimum or maximum point of my parabola, and I already know the x value of it. I know it has to be somewhere on this line, so x has to be 1. When I plug in x equals 1 into my formula, I'm going to get 3 times 1 squared minus 6 times 1 plus 2. I'm expecting to see this work. 3 times 1 minus 6 plus 2. 3 minus 6 plus 2 is going to be 5 minus 6, which is negative 1. So I get over 1, down 1. That is my vertex. I should use red. Does this parabola open upward or down? We know because it's positive, it's happy, it's a smiley face. It's going to be opening up. Okay, and it should be going through that parabola, but we're not sure how thick it is or how wide or stretched it is. Okay? Because it's a 3, it should be stretched somewhat, right? So let's go ahead and make like a little table. XY. And I'm going to plug in 0. If I plug in 0, I get 2. Over 0, up 2. Bloop. So that means right here would be another one. You could check up higher or back further, like at -2, or you could check at, you know, +3. But I'm alright with that right now. Okay? Oops. Just go through the points. Alright? Graph paper will be helpful. Alright, another thing that we're going to talk about are, and I've been trying to refer to them too as I've been going over these, but minimum and maximum values are helpful when we have to state the domain and range. But when you have a positive A value, you're going to have a minimum value. Your vertex is your minimum. So then when you're describing your domain, remember the domain is anything left and right. It's like all your X values. Your range is anything up and down. So we need to describe the domain. The domain are X, and what can my X's be? My X's can be anything, can't they? Because this is going to keep going out and out and out and out. So X can be all reals. My Y, though, cannot be below 0. That's my minimum value. So Y is going to be greater than or equal to 0. And then down here, domain, it's just going to keep going over and over and over, and it's all the X values. So it's going to be X is all reals. And then range is going to be less than, it looks like 1, 2, 3, 4, 5, 6, 7. So X is going to be, oops, less than or equal to 7. Now, just so you know, we're doing domain and range, and we've done it on linear equations, we've done it on exponential equations, but with the parabolas, pretty much every single time, the domain is going to be all reals. But I want you to be able to look at the graph and know that. So don't just memorize it and say, oh, it's always all reals. Look at the graph and say, yep, it's going to be all reals, but just know that you're not wrong always getting that same answer. Okay? This is something that's pretty cool. I want to show you in class, but this is just changing. If I change the equation over here, you can see how if I make that a bigger A value, how it stretches it. See that? If I make it the parent graph, oops, I just made it negative. See how that flipped it over? But I'm going to try to make this as close to the parent graph as I can. Alright, so we're going to have one of those and 0. So there's the parent graph. And then if I change the C, which that should move it up and down. See how 1, it goes up 1, up 2, plus 3, it's going up. And then if I go down, it's still the same width. It's not changing that at all. It's just, this is just moving the parent graph up and down. So that's C. Now if we change A, that's where I stretch it. Okay, it's stretching it. And then let's go down. Oh, making it negative. Okay. Parent graph again. Now I'm changing B. Now that's a weird movement, isn't it? So that's where we find our vertex, and that's where it's, see how it's moving left and right. Okay? Alright, good luck. This is 10.2. We'll work on this on Monday, and I will see you then.